Hi students, today we are going to find elevation of maximum height of the projectile from the point of projection. Here elevation will be with respect to horizontal. We know if a projectile is thrown at some angle, say theta, with initial velocity u, then the trajectory of the particle will be like this, a parabolic path. In this parabolic path, we know that its maximum height point is symmetrically located about the point of projection and point where it lands. If I call point of projection to be O and point of landing to be L, then this point P is exactly midway between O and C. Particle is at its highest point at this place. So if we want to find out the elevation of that point while it is at maximum height, can be easily obtained by the slope of this line OH. We know that this is the maximum height attained by the projectile, and this distance is horizontal range divided by 2, because such parabola is symmetric about its highest point, means the nature of the curve is same at this side and this side also. If I write this angle to be phi, then phi is called angle of elevation of point H with respect to point O. So phi can be calculated here from the given circumstances H, because in triangle OHP, if we write H upon R by 2, it comes to be tan phi, because H is perpendicular here and horizontal distance is R by 2, means range divided by 2. From this scene, we can write value of H to be u square sine square theta divided by 2g, and horizontal range R, it is u square sine 2 theta divided by g. Putting these two values in this equation, we get tan phi is equal to 1 by 2 tan theta. And this was our main target. So students, I think you are now clear about this fact, that what is the elevation of a projectile when seen from the ground. So elevation comes to be phi equal to tan inverse half of tan theta, where theta is the angle of projection. Observation of an observer sitting on a projectile and trying to see the path of some other projectile which has been thrown from the same point with some velocity at some angle. Say we have thrown two projectiles from the same point and at same time with different velocities. The first one with velocity u1 at angle theta, and the other projectile is thrown with velocity u2 at some other angle theta 2. Say at any instant projectile 1 is at this place and projectile 2 is at this place. Now projectile 1 is seeing the projectile 2. If I take positive x direction towards the horizontal as earlier and y direction along the vertical, then for the two projectiles I can differently write coordinates of those projectiles. Just see for projectile 1 and projectile 2. For projectile number 1, we can write x position x1 of the projectile to be equal to u1 cos theta 1 into time t, while for projectile number 2, this x coordinate comes equal to u2 cos theta 2 into time. If we talk about the y coordinates, then y coordinate for the projectile number 1, say it is y1, then y1 is equal to u1 sine theta 1 into time minus half gt square. And for the second projectile, this y coordinate y2 can be written as u2 sine theta 2 minus half gt square. So relative position of projectile number 2 with projectile number 1 can be written as x position equal to x2 minus x1 or u2 cos theta 2 minus u1 cos theta 1 times t, and y can be written as y coordinate of second projectile minus y coordinate of first projectile, or y can be written as u2 sin theta 2t minus half gt square minus u1 sin theta 1t minus half gt square, but these terms are in brackets. So while opening these brackets, we can get y equal to u2 sin theta 2 minus u1 sin theta 1 multiplied by time t. Now, if we find y upon x, then it will become u2 sin theta 2 minus u1 sin theta 1 divided by u2 cos theta 2 minus u1 cos theta 1, and if you see, this result is constant. So we can write y is proportional to x, which indicates a straight line. So we may call that path of one projectile as seen from other is always a straight line. Here one projectile is flying, its acceleration is g downward, other projectile is also flying, its acceleration is again g downward. If we try to find out the acceleration of one projectile with respect to other, then you will find that projectile 2 moves with constant velocity with respect to projectile 1, and that's the basic cause which tends the path of one projectile with respect to other to be straight line.